As I promised in the first botnet malware analysis video, this video for Overachievers will take you through a short guided tour of the RxBot's source code, and it will also teach you a little bit about how bot herders use packing and encrypting to protect their bot clients. I'm going to start out in the directory where I stored my RxBot variant. After downloading and uncompressing it, this is what I ended up with. At first glance, it just looks like a whole bunch of files. These are a mix between C++ files and normal C++ header files. But if I scroll down a little more, I see some different types of files. These are Visual Studio files that organize this code project. This one here is actually the workspace file. If I double-click it, it opens up Microsoft Visual Studio. In Visual Studio, we see this project is divided between source files, which are the C++ files, and header files. The main thing I want you to notice about this code is that it's very modular. Each individual feature for the RxBot has its own code module. This makes it very easy for the bot herder to quickly add new modules if he wants his bot to do something new, or remove modules if he wants his bot not to do something and to make it smaller. So this modular design is very powerful and makes it very easy for this bot herder or anyone else that shares this source code to quickly modify the bot from this base source. So let's jump right in and check out RxBot's configuration file. This file is found under the headers and is called configs.h. We're going to go ahead and open this file, rearrange the screen a little bit, and go through it line by line. Starting with the first thing it's asking for, the server port. This represents the port your IRC command and control server is going to use. You can make this anything you want. IRC's default port is 6667, but Spike used 54321 to make it different. You'll also notice the backup server port. If you want to have a secondary IRC server in case your first one goes offline, this is where you can define its ports. It can be the same thing or it can be different. After these two ports, we have ports for various servers, including a SOX4 proxy server, a TFTP server, an HTTP server, and an RLogin server. All of these types of services have default ports that most people on the internet use, like HTTP or web traffic uses 80. But if Spike wants to be sneaky, he can change this port to something else. Next, we see a setting called topic command. In an upcoming botnet video, you're going to see how Spike can set a IRC channel topic and make that a command for his bot. If you want to use this feature, you have to set that to true. If we jump down to debug logging, this tells the bot where to store a log file. I think it's kind of funny that the default is to name the log file yaz.jpg. So even though it's a text file, we're naming it as though it were a picture to kind of trick the victim so that they can't find the bot's log file. So let's quickly skim through the rest of the settings. Bot ID is just a name you want to give your bot. The version is what particular bot version you're running. You can totally make this up or use whatever the bot is. The password setting is obviously where you set what password you're going to use to connect to the bot. The server is the IP you're going to use for your IRC command and control server. The server pass is the password you're going to use to connect to that IRC server. The channel setting is where you tell your bot what channel to join by default. And of course, the channel password is the password it needs to use to join that channel. We also have server 2, channel 2, and channel pass 2, which are all the same settings as I mentioned before, but they're for the redundant backup IRC server if you chose to configure it. File name's kind of interesting. It's the name you choose for the actual executable file that resides on the victim's machine. In this case, it's stored in c:/windows/system32. Spike chose the name avscan32.exe since he figured people would think it's an antivirus scanner. Next is the name of your log file for keylogging. The next setting, value name, is also interesting. It's the value name for the registry entry RxBot's going to add in order to automatically start itself on the victim computers. Again, Spike called it AV scanner to convince him it was an antivirus scanner. Let's skip a few of these settings because they're not that important and drop down to exploit channel, keylog channel, and packet sniff or psniff channel. These are all where I can choose different IRC channels for my bot to report things like if it's exploited any vulnerabilities, where it might log some keystrokes, and where it will log its packet sniffs. But to make everything simple, Spike went ahead and just made all of these the exact same channel. We've gone over the most important configuration settings in RxBot's config file, so let's move on. So you've seen how modular RxBot's source code is, and you've had a good look at its config file. Now all that's left is to go through each of the modules, which we simply don't have time to do, but let me give you a quick overview of the more interesting ones. First of all, CD keys is kind of interesting. This is the code the attacker uses to steal CD keys or serials from his victims. As you can see, in this module is a big list of registry locations that the bot knows where to find different CD keys for different programs. In this case, most of them are games like Counter-Strike and Half-Life. However, we also see a Windows CD key in a lot of EA games as well. If you know a CD key that you desire for any piece of popular software and you know where that's stored in the registry, you could easily modify this bot to steal that key as well. Another interesting module is processes. In this module, the bot herder lists all the processes he wants his bot client to kill on his victim's machine. You can see this is a huge list. It includes the processes used by many popular antivirus software, firewalls, security software, all kinds of popular programs out there that the bot herder doesn't want running on his victim's machine. Here at the bottom, you can even see some processes that aren't security software, like bbeagle.exe for instance. bbeagle.exe is the process name for a very virulent email worm that came out a while ago. Obviously, the RxBot author doesn't want to compete with that worm, so he goes ahead and kills it on his victim's systems. This auto-start module is the code the bot client uses to add itself to the victim's registry so that it can start automatically. The bot client uses the capture module to capture screen images or images from webcams and video as well. In our next video, you'll see an example of this, and this is the particular code module that makes it possible. Find password is a neat little trick that works against Windows 2000 and WinNT machines. This module actually allows the bot client to pull the victim's password from memory and send it to the bot herder. Oh, and of course the most important module of all, rbot.cpp. This is the core code for the worm, so we're going to make this big and take a closer look at it. It's pretty huge. It does everything from telling the bot how to connect to IRC to how to decide what's a command and what's not a command. It's basically the bot's main brain. But if we scroll down far enough, this also contains all the commands the bot knows. So if you download a bot and don't have any instructions how to use it, this is the code you'd have to parse to figure out what it understands. For instance, here's some commands right now. SOX4 is the command to start a SOX server. There's the command to stop it. There's the command to stop the HTTP server or stop logging. Anyways, as you can see, there's just a ton of commands, and if I didn't know them from some sort of manual, since most of these don't ship with one, I'd have to go through this code and figure out all the commands the bot knows, and perhaps figure out what they do. Oh, here's an interesting one, the mass scan command. The mass scan command is the command that tells the bot to attack a network with all the vulnerabilities it knows. Usually this is called mass scan, however Spike renamed the command to foff. So as you can see, there's a lot of code. We've barely scratched the surface, but you get the general gist. These bots are pretty complex and offer a lot of power. Now all Spike has to do is go up and build his bot. After compiling their bot client, An attacker can put it through two optional processes that will help it spread more easily and bypass a lot of security vendors' software. These processes are called packing and crypting. Packing makes the bot client smaller. Smaller files spread over the internet much quicker. Crypting encrypts the bot client so that AV scanners and other security software can't detect it. As you can see, I'm in a folder with three files. rbot.exe, which is my rbot client I compiled earlier, pepack.exe, which is my packer, and this file here, which is an underground crypter that I just downloaded recently. Before we pack and crypt it, I'm going to show you what happens when antivirus vendors scan our unmodified bot client. I'm going to a site called virusscan.joti.org. On this site, you can upload a suspicious file and have it scanned by many antivirus engines. We'll start by uploading rbot.exe. Remember, this is the version of rbot that has not been packed or crypted yet. This process takes a little while, so we're going to speed up this video. Wow, look at that. Already many of these antivirus vendors have detected this accurately as rbot. So now let's go back to our folder. First, we're going to start by packing our rbot client. To do this, I go to the DOS prompt and type this command. This will pack our bot client and generate a file called output.exe. I'm going to rename this file to packed.exe so I remember what it is. Notice the original rbot.exe file was 354 kilobytes, but this new packed file is 149 kilobytes.